Good afternoon, all of you. Good afternoon, Kadambari ma'am.
Good afternoon. Shall I start? Can I start? Dr. Shilpa.
Yes, ma'am. Participants are joining.
Sorry? Can't hear you.
Yes, ma'am. Good afternoon, everyone. Yes, ma'am. Am I audible?
Yes, you are.
Am I audible, ma'am? Am I audible?
Yes.
Hello. Hello.
Shilpa ma'am, you are audible. Shilpa ma'am. Okay, leave it. Hello.
Hello.
Yes, sir.
Hello.
I think Shilpa ma'am, you are audible. Shilpa ma'am.
Yes, ma'am.
Okay. Hello.
Hello.
Yes, ma'am.
Yes, sir.
Hello.
Yes. I think Shilpa ma'am, you are audible.
Okay, okay. Thank you, ma'am. Kandabari ma'am, are you there?
Yes, I'm very much here.
Okay, okay. Thank you, ma'am.
Yes.
Okay, okay. Okay. So we can start the session. Ma'am, are you there? Good afternoon, everyone.
Yes, I'm very much here.
Okay, okay. Thank you, ma'am. Okay, ma'am. Good afternoon, everyone. I welcome all of you to the another insightful session of
We
day
can
3.
start the session.
Let's get ready to learn from our experts and broaden our knowledge.
Yes, I'm very much here.
Okay, ma'am. I welcome our speaker of the session, Dr. Kadambari ma'am from NIT Warangal. I speaker of the session. Currently, she is working as an associate professor and completed her PhD from the School of Computer and System Science, JNU, New Delhi, in 2011. Her area of research is computational neuroscience. Earlier to that, she completed her M.Tech from Andhra University. She has published more than 30 research papers in various journals and reputed books. I would request Dr. Kadambari ma'am to begin the session and share his expertise with us. Ma'am?
Yeah, okay.
Yes, ma'am.
I hope the screen is visible to everyone and I'm audible to all.
Yes, ma'am.
Acha, okay. I'll start. Today I'm going to talk about decision trees, and after that I'll be
Yes,
dealing
ma'am,
with
you're audible.
ensemble learning. I hope the screen is visible to everyone and I'm audible to all. I don't
Yes, ma'am, it is
understand
visible.
why
Yes, ma'am.
is it getting repeated.
On kar liya?
Yes, ma'am.
Okay, I'll start. Today I'm going to talk about decision trees, and after that I'll be
Yes,
dealing
ma'am,
with
you're audible.
ensemble learning. I hope the screen is visible to
Yes, ma'am, it's visible.
Okay, so let me start off with the concept of decision trees. In case of machine learning, this decision trees falls under the concept of supervised learning. And in case of supervised learning, we have a designated class label for every input vector or input data that we are feeding. And for the case of training, we have these set of class labels. And if you're trying to classify an image, then for each associated image, you would be having its name or some description in the class label. Then apply a technique of feature extractor, extract the features, and then feed it into the machine learning algorithm. So this machine learning algorithm that you're seeing here, that is being trained already on this set of images. So you have a trained machine learning algorithm which knows that for a corresponding image, there would be a class label. So using this trained algorithm, or call it as a trained classifier, we feed it with a random image, something where we are not giving the label of the image. Okay. And then from there, we extract the features again, study the features, and the trained classifier will then tell us what is the class label. Okay. So this is what we do in case of supervised learning, where you have some set of inputs and their corresponding are the features are nothing but class labels. Study the features and the
Excuse
trained
me,
classifier
Kadambari
will
ma'am.
then tell us what is the class label.
Excuse me, Kadambari
Okay.
ma'am.
So this is what we
Hello?
do in case of my voice is echoing again. Can someone do something about it? And their corresponding are the features are nothing but class labels. Study the features and the I hope it doesn't happen again. My voice is echoing again and again. Is it okay now?
Yes, ma'am.
Let me
Hello?
just re-log in.
No, ma'am. Now it is clear.
Actually, your voice is also not audible to me. That's the problem. Like it's coming very faintly. Is it okay now?
Yes, ma'am, you are audible.
Now your voice is also audible, clear. I'm good.
Okay, ma'am.
So I was talking about the supervised learning part, and as I said, decision trees happens to be a supervised learning algorithm where for a input variable or an input data item, tuple as we call it, you would be having an associated class label. So coming to the different types of machine learning algorithms, you have so many of it. Some are decision tree learning, regression techniques, artificial neural networks, Bayesian, then genetic algorithms, SVMs, etc. And coming to the main concept of the day, which is decision trees. So we define decision trees to be a rooted tree which has a root node, and then you have a set of children, and then you have leaf nodes. Okay, so it's something similar to what they call a binary tree, which we have studied in our data structures, etc. But it resembles this binary tree, but not exactly the properties of the binary tree. So, in order to show how this works, let me just open the whiteboard. Where's the whiteboard here? Where's the board in this? Like it used to be there here earlier, right?
Ma'am, the option should be on the extreme right, just next to app.
Sorry.
Just next to apps on the right at the bottom of the screen where share screen is written. Then you see many icons, and extreme right, you will find whiteboard
Extreme right.
at the bottom where
I
where the
can't
share.
hear you.
Can you hear me, ma'am, now?
Yeah.
Volume is less.
There's nothing in this.
Ma'am, bottom right.
Bottom right.
Just before that leave button, you will find whiteboards.
On the PPT.
No, ma'am. On the Zoom app.
Yeah,
Zoom,
I've gone to that only.
yes, ma'am. Zoom, there is a menu at the bottom where you have participants, chat, share screen, record, reactions, apps, and then it is the whiteboard.
There's this app.
Ma'am, the Zoom interface that you have from where you are sharing your screen, you can stop the share and then you can see. Stop sharing the PPT and then you can see.
Got it. Okay. So coming to the definition, yeah, is it visible?
Yes, ma'am, it is visible.
Coming to the definition of decision trees, we can define it as a tree structured classifier which has two types of nodes. One is called as your decision node, and the other one is called as your leaf node. Okay, and decision nodes are those nodes on which conditions are checked. You can also write it as testing the value of an attribute. Okay, so if you guys remember this, during our first year of programming, we learned what is an algorithm. We also learned what is a flow chart, and in a flow chart, we had this rhombus symbol in which we had given some conditions. Like for example, if I write if x is greater than 10, then you would be having two outputs, either a yes or a no. So if it's a yes, then I would say print x. Okay, otherwise I would say x is less than 10. Okay, so this is what your decision node looks like, even in a decision tree. And the output that you're getting here out of each decision or out of each condition, that is called as your leaf node. Okay, so these are the outputs of your decision, whether it is greater than 10 or less than 10. These are called as your leaf nodes. Okay, so in technical terms of machine learning, leaf nodes, they give you the classification value or value of a particular example. Fine. Now, let's take some examples down and see how actually a decision tree can be constructed using the two terms that we have just now learned. One is the decision node and the other one is the leaf node. So let's see how they are represented in a decision tree. So this particular example, it talks about whether or not to approve a loan application, okay, when you go to a particular bank. So the idea is whether or not to approve, I can represent it as approve or reject a loan. So for this, I am taking some attributes related to this particular example. So the first attribute happens to be employed. Okay. So I am seeing whether the person is employed or not employed. That means employment is yes or no. Whether the employment is yes or no. Suppose, if the employment value is no, okay, then I take another variable which is called as credit score. Okay, this variable, I will check if it is high or low. All right. So if I say the person is not employed and the credit score is however high, then I approve the loan. So this is my decision. Okay. And if the person is not employed and the credit score is low, then I would say reject the loan. So this way I've reached a decision. Like first I have given as employed, which is equal to no, then credit score equal to high, then class label would be approved. So in this way, you would be constructing the decision tree. Now let's move on further towards the right-hand side. I'm saying the person is employed, that is yes for employment. Then I check the person's income. And income also takes two values, high or low. If the income is high, then approve the loan. If the income is less, then reject the loan application. Okay, so this is the first example of our decision tree. So how we can use this decision tree? How can we use this decision tree is if the host is available, can you please allow people to enter the room, because it's like wasting my time. It's popping on my screen all the time. So how to use a decision tree? We can say that if an applicant is employed and income is low, then reject the loan. If the applicant is not employed but his credit score is high, then approve the loan. So this is how you can use your decision tree concept. And moving on further, let's take an example of a continuous variable, okay, where we show how to construct the decision tree. So in this example, we are checking if a person will buy a computer or not. Will buy a computer or not. Okay. So the class labels are yes and no. The class labels are yes and no. So for this, the attribute that I'm going to take first is age. Because in general, we don't expect a 70-year-old or an 80-year-old to buy a computer, right? So that's why I'm taking the age as an attribute. And since it's a continuous value, age takes continuous values, right? So what I'm doing is I'm segregating it into categories. I'm putting them into categories. I'm taking less than or equal to 30 is one category. Then 30 to 40 is another category. And greater than 40 is another category. Okay. So since age is a continuous variable, we are dividing it into two or more groups. So let's talk about the leftmost side of the age, which is less than or equal to 30. And in here, I take a variable student. The reason being that we generally expect that people below 30 years are students, right? And students in general would be buying the laptops or buying the computers for their study purposes. So if the person is a student or not, that's what we need to check. So the inputs that the variable student would be taking are yes and no. If the person is not a student, then it's like highly unlikely that the person will be buying a computer. And if the person is a student, then it would you would have a lot of probability that the person will buy the computer or the laptop. Now coming to the 30 to 40 years age group, most of them are professionals, working class. And here compulsorily we require a laptop. So without any ambiguity, I say that the person would be buying a laptop or a computer. Okay. Now coming to the third type, that is greater than or equal to 40, I'll take another variable called as credit rating. Okay. And I'll check if the credit rating is excellent or poor. Okay, so if the credit rating is excellent, then I say I will not buy the laptop. And if the credit rating is poor, then I will say I'm buying the laptop. Okay, so these are the two examples, and by which you can actually see very clearly that this is how your decision tree can be created. Okay, and to move further, like we can have one more example. And this is about car mileage prediction. Okay, so I'm taking a variable called as weight. And this weight, I'm checking if the car's weight is heavy or not. I'm checking if the car's weight is heavy or not. So that is yes or no. Okay. So if the car's weight is heavy, then I say that it would give me a high mileage. That's how I'm going to predict it. And if the what they call car's weight is less, then I take the horsepower, which is less than or equal to say 86. And if this condition is met, I mean, if this condition is true, then the mileage would be high. Otherwise, the car would deliver low mileage. Okay. So these are some set of examples for construction of a decision tree. Now, the main question here is that given a particular data set D, we have a particular data set D, we need to construct a DT for this particular data set, right? We'll have to construct a decision tree for this particular data set. That means using the variables or attributes present in this data set. So the question that I want to ask you is, for a given data set, you would be having many decision trees. That means for some training examples, you would be generating many decision trees, right? But out of these decision trees that you have created, which one is the best fit for the data? Now, what do you mean by best fit? What do you mean by best fit? Best fit in decision trees basically means that you are giving the correct class label at the end of each path, right? So that's what we mean by best fit, correct? So, but given thousands of tuples and their corresponding features, okay, you can create multiple decision trees.
Ma'am, please repeat do you mean by best fit? Sorry to interrupt.
Best fit is nothing but you're getting the correct class label for the corresponding input data. Right? We'll see how to create this best fit also. Like you can't just construct multiple decision trees because as you might have seen here and in the previous example, if you have more number of tuples, more number of input data and more number of features or attributes, your decision tree length would increase. The depth and size of the decision tree would increase. And there it becomes very difficult to spot the correct class label for a corresponding input data item, right? So given all these decision trees based on these input features and this input data items, which among these decision trees would be the best fit for the data? That is the question. So the answer is simple. Prefer So it's called as Occam's razor. It says that prefer smaller trees which have low depth or less number of nodes. Okay, so when you have multiple decision trees, you select trees which have lesser depth and less number of nodes. Okay, so that is the main idea for choosing the best fit tree. So in general, if I say that this decision tree is best fit, that indicates that it is a smaller tree with lower depth and with less number of nodes. And at the same time, you would be accessing the class label within less amount of time. Because if you have large trees, it becomes difficult for the computer to find the class label. But if you have short trees, then it's easy, or it consumes less time to reach to the class label. So that's the main idea. And this principle is called as Occam's razor. Okay, it's called as Occam's razor. Now, moving further, let's take one example, and we will see how to construct this decision tree. Okay, and find out the values of unknown inputs. So in this example, we are checking whether a user reads or skips a thread or otherwise called as a post on Twitter or Instagram, etc. Okay, so the data set looks like this. There are attributes. The first one is called as user. The second one is called as the author. Third one is called as the thread. Fourth one is length. Fifth attribute is where. And the last one attribute that is called as your action. It is also the class label. Okay, it's also called as the class label. So you have users labeled E1, E2, E3, so on. So E1, let's see what E1 does. So author takes two values, known and unknown. So E1 is a user. He knows the author, and the thread is new. That means newly posted. Length happens to be long. That means it's a long post. And where did the user read? He read it at home. And the action was like he skips. That means he didn't read it. So coming to E2, author is unknown. Thread is new. Length is short. Where? So E2 read the thread. Then you have E3. It's unknown, old, long, work, skips. You have E4, which is known, old, long, home, and skips. E5, is known, new, short, home, reads. E6, the last user, known, old, long, work, skips. So this is the training data set that we have. Okay, using this data set, we need to create a decision tree and then give the values for E7 and E8. And these are the attribute values. So you need to tell what action E7 and E8 are taking. Okay, so for this, we have to find out the values. But to find the values, we first need to create a decision tree, right? So in technical terms, we say that learn a decision tree so that when we get a new example like E7 and E8, we can find if a user will read the post or skip the post. So now let's see how we will actually build this particular decision tree using this data set. Okay. Now what I do is like I pick up a random attribute. So the attributes that we have, I mean, this we cannot pick users because we need to predict on them itself. So we will pick up these attributes, that is author, thread, length, and where. Okay, either of these attributes I'll pick up and then I'll start constructing the decision tree. So let me pick up the attribute called as thread. And thread, it takes two values. One is new and the other one is old. So it's taking two values, new and old. Now let's construct the decision tree based on the thread attribute. So look at E1, E2, E3, E4, E5, E6. Okay, how many thread values are equal to new in this?
3.
How many are equal to new and how many are equal to old?
3 new,
How
3
many?
old.
1, 2, and 3. Correct? Yeah,
Yes, ma'am.
and then we have 3 old. 3 new and 3 old. That makes it what they call total 6. Fine. Out of these, okay, when thread is equal to new, that is when t equal to new, how many skips you have and how many reads you have? How many number of skips and how many number of reads do you have when t equal to
2
new?
skips, skip 2 reads.
So you have 2 skips
No, ma'am,
and
1
1
skip.
read?
No, ma'am, the other way around. I think it's
Sorry?
1 skip and 2 reads.
Acha. So
1
I'll
skip.
make this read
Yes.
and 1 skip. Okay, and what about this? Huh?
All skips. 3 skips.
When thread is old, is it all skips?
All skips. 3.
Okay. So there's no ambiguity here. So I say that when thread is old, then users would be skipping the thread. Fine. Now here we have a problem, that is we have 2 reads and 1 skip. That means we have ambiguity. So we need to further expand the tree. Okay, we need to expand the tree. And how we will expand the tree is by taking another random variable, another random attribute. Okay. So let me take an attribute called as length. So when thread is new, okay, length can take 2 values. It's taking 2 values. One is long and other one is short. Fine. So let's take these 2 values. When thread is equal to new and length is equal to long, check from E1 to E6. How many skips and how many reads?
Ma'am, the long one is skipped and the short ones are read. Both.
क्या है?
Long one is skipped, one long skipped, 2 short, they're read.
So long basically it skips and short is
Read.
read.
Yeah.
There's no ambiguity, na?
Yes, ma'am.
Yeah. So we have reached our leaf node, but what we did, we used an attribute length. We also used an attribute thread. Fine. Now let me take another decision tree where I'm taking the root attribute to be length. And like we said, length takes 2 values, long and short. So when length is long, how many skips and how many reads?
Length is long, 4 skips.
All skips, right? And here all reads. Am I correct?
Yes, ma'am. Both short are read. Yes, ma'am. No ambiguity. Both short are
All
read.
reads, yeah. Yeah. So now these are the 2 decision trees that we have created. Right? These are the 2 decision trees that we have created. Now, among these 2 decision trees, which one would you prefer?
The one with the length.
The one with the
Length. Root
length
length.
one, correct?
Yes, ma'am. Yes.
Yes or no?
Yes, ma'am. The depth is low here.
Yeah, why? Because the depth of the tree is less and it has less number of nodes. Correct? So
Yes,
this
ma'am.
is this is the best fit tree that you can create for this particular data set. Fine. And this is how you're supposed to create the decision tree. But now this brings us to the next stage or the next question. How would you actually select, or which attribute would you select to be the root node? The reason why we are saying root node is because we want the tree to be of less depth and less number of nodes. Fine. So which node would you be taking as the root node? Which node you would be selecting as the root node? So that's the main crux of decision trees. Fine. Now let's see, how do we select, given some set of attributes, how do we select the best node or the root node? So for this, what we are doing is we are considering this example of Sania Mirza's training session. And this training session we are taking for 2 weeks. Okay. And we are recording her session, whether she will be playing or staying at home. Okay. Based on weather condition. So the example is, we had observed Sania's training status for 2 weeks with respect to weather conditions. to be able to expect if she will play or stay on a certain day at home. Fine. So this was our idea, or this is our example. And this is the data set that we have. As I said, action indicates the class label. And the attributes are wind, temperature, outlook, and humidity. Wind takes two values, weak and strong. Temperature takes three values, hot, mild, and cold. Outlook takes three values, sunny, rain, and overcast. And humidity takes two values, high and normal. Okay, so the question is, out of these four attributes, which one will you select as the root attribute? Why we are selecting the root attribute? To create the best fit decision tree. Okay. And for constructing the trees, we have different types of algorithms. The first one is induction decision version 3 algorithm, ID3. Then you have C4.5 and C5. In today's class, we'll be dealing with ID3 for constructing the decision tree. So to draw a decision tree from a set of attributes, we need to create, or we need to select the splitting attribute. We say that a splitting attribute is the most informative attribute among the list of attributes that we have. Okay. And each arc represents a possible value for that attribute. So how do we select this splitting attribute is by using two concepts. One is called as entropy and the other one is called as information gain. So entropy is a factor which is used to measure how informative a node is. That means how much information the node is giving with respect to the data set. That means, is it more informative or is it less informative? Okay, so that's the idea behind entropy. And how do I calculate or how do I find out if the attribute is good enough for fit or good enough to be the root node is by using the concept of information gain. Okay. Fine. So the attribute with the greatest information gain value will be taken as the splitting attribute, and the data set is split for all distinct values of the attributes. So let's calculate entropy. So entropy is actually the measure of uncertainty. It came from the concept of information theory. Okay. थर्मोडायनेमिक्स में एक क्या नाम है, एक थियरी था इंफॉर्मेशन थियरी करके. It states that every information can be represented using zeros and ones. So ये 2 bits use करके we can represent the information. तो उसी के बेसिस के ऊपर ये एंट्रोपी आया है. We say that the entropy is the measure of uncertainty. So let's give some examples. Let's discuss some examples here. So very soon in November 2024, we would be having what they call presidential elections in the USA. So wahan pe, if I ask you to predict who is going to win, that is whether Democratic Party will win or whether Trump will win, That is what I want you to predict. So if I ask you to predict that, so it would be very difficult because it's all like 50-50 chances, right? But then recently when the Lok Sabha and Rajya Sabha elections had taken place and we had to select our Prime Minister, and if I had asked you that time who would be winning, and most of you would be confidently saying that it would be NDA, right? Some people with greater confidence would have said that it would be INDIA bloc, correct? So the answer that you are giving with greater confidence represents the certainty of that event happening. Another example that I can give you is the sun rises from the east. The sun rises from the east. Is there any uncertainty in this event? Is there any uncertainty?
No.
That means it is 100% in the sense this event will 100% occur. That is, sun always rises from the east. That means there is no uncertainty. So for such events where the certainty is very high, for them the entropy value would be less or almost zero. And for events which have 50-50 chances, that means entropy is high, okay, because there is 50-50 chance, the entropy value would be 1. Okay, so entropy can also be treated as the chances of an event to occur, okay. We'll talk about this definition, that is measure of characterizing the purity of a data set a bit later. Let's talk about how to calculate entropy first. Given a training set D with two classes, capital P and capital S of the target, that means you have two class labels, P and S. Okay. So these are the two class labels that we have. And we are taking two variables, small p and small s. Small p represents the fraction of capital P, small s represents the fraction of capital S. That is number of capital P's by total number of records, which is 14. Similarly, number of capital SS by total number of records. So it's nothing but the fraction. And entropy, that is entropy of the data set D, is given as minus log 2P minus S into log 2S. Here P represents this small p, that is the fraction. S here represents this S. Okay. So this is the equation for entropy. Now, given this table or given this data set here, if we have a collection of 14 records, we have 9 P's. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So small p would be 9 by 14 and s would be rest, that is 14 minus 9 kitna hua 5. So it would be 5 by 14. So in dono ka fraction aa gaya 0.64 and 0.35. So entropy would be 0.643 into log 2 of 0.643. The reason why we have used 2 is because of this concept. Bits information can be represented using 2 bits, zeros and ones. Okay. So the entropy, the total entropy value we have got is 0.94. That means the data set is quite uncertain, means you cannot clearly predict whether you're going to get a positive, whether your tuple is going to be in a positive class or whether your tuple is going to be in a negative class. So 94% uncertainty is present in the data set. So this was the equation for entropy. Now, as I said, if all records belong to the same class, then entropy would be 0. If records are equally divided, that means if you have 50 to the positive and 50 to the negative class, entropy would be 1. And given k set of classes, that means k classes, this is the entropy equation. Sigma I equal to 1 to k minus pi log to pi. If, for example, k is equal to 4, then you have minus p1 log to p1, so on and so forth. Minus p4 log to p4. Okay. So moving on further, let's define the information gain. So we did calculate the entropy of the whole data set. E of D represents entropy of the whole training data set. Please remember this. ठीक है, इसका हमने एंट्रोपी फाइंड आउट कर दिया. अभी हमें क्या करना है, स्प्लिटिंग एट्रीब्यूट को फाइंड आउट करना है. विच वन इज द स्प्लिटिंग एट्रीब्यूट? सो लेट्स लुक एट दिस टेबल. इसमें हम क्या कर रहे हैं, वी हैव वन वेरिएबल, वन एट्रीब्यूट विच इज कॉल्ड एज v, and v takes two values x and y. ठीक है, तो हमें अभी क्या करना है, इंफॉर्मेशन गेन फाइंड आउट करना है कि v स्प्लिटिंग एट्रीब्यूट कहलाने के लिए काबिल है या नहीं, whether v is good enough to split the data, split the decision tree, okay, or split the tree. That we need to find out. So for that we use the equation for gain. Okay, information gain of d with respect to v, that is how we pronounce it, call it, and that is given by the total entropy minus the entropy of individual value of v, okay, into its total entropy. So don't need to like get tense here. We will see how we can calculate this one, this part. Okay. So ED तो हमें पता है हमने कैसे कैलकुलेट किया, अभी इसको हम डेड्यूस करते हैं. ठीक है, so let's do it. We are saying v takes two values x and y. So for each value of v, for each value of v, when v is equal to x and when v is equal to y, we need to calculate the entropy. ठीक है, तो उसके लिए हम क्या करेंगे, we'll see when v is equal to x, how many plays and how many stays we have. So first of all, कितने x हैं, that is how many records are there where v is equal to x. Can you please count and tell?
8.
8. Okay, very good. So we have v equal to x is equal to 8, or v equal to y equal to कितना?
6.
Very good. अभी हम क्या करेंगे, when v equal to x, we need to calculate entropy of x. अभी x की वैल्यू, entropy of x कैसे calculate करेंगे?
Fraction of x, that is 8 upon 14.
हाँ. So what we need to do, we need to say when v is equal to x, how many number of p's and how many number of s's we had, है ना, वही तो fraction हो जाएगा ना.
Yes.
है ना. हाँ, तो अभी बताएं e of x कैसे बनेगा. I'll write it like this, minus p log 2p minus s into log 2s. So अभी ये कितना होगा बताएं?
We have 6 plays for X.
6 plays. So it is minus 6 by 8 into log 2, 6 by 8. And rest is 2 by 8 into log 2, 2 by 8.
8.
That is E of X. Okay. Now on a similar note, let's do E of Y.
I think Y there are 3 plays.
3.
3 plays for Y.
So Y has equal.
No man, 3 plays. Yeah.
Yeah. So obviously you would be having 3 stays as well, है ना?
Yes, total number is 6.
हाँ तो वो इक्वल हो गया ना, तो ये 1 हो गया ना. अभी तो हमने बताया previously, if records are equally distributed over collection, entropy is
Maximum 1.
yeah, 1. So your gain then would become gain of D comma B would be 0.94. We already had calculated for E of D earlier, minus 8 by 14 into whatever value you are getting here, that is E of X, plus 6 by 14 into whatever value you are getting, it's 1 here, so that's what. Okay, and it's already given here 0.94 minus 0.892. It becomes 0.048. So this is the information gain of attribute B. Information gain of attribute B. So in dono logics के साथ we would proceed further for the Sania Mirza example. But हर एक attribute का हम information gain calculate करेंगे और जिसका भी information gain value ज्यादा होगा उसको हम splitting node के तौर पे लेंगे, ठीक है? So let's calculate for wind. Wind takes 2 values, weak and strong. And weak jab tha, we had 7 plays and 2 stays. Strong jab tha, we had 2 plays and 3 stays. Okay. So the gain of wind that we have got is 0.102. Similarly, temperature, as I said, it takes 3 values. The gain for temperature that we got is 0.008. And outlook, we have got 0.424. And last one, humidity, got the value of 0.016. Okay, among these 4 values, which one will be the splitting node?
Outlook has 0.4, right, ma'am?
Yeah.
And wind has 0.1, I believe.
So which one is the splitting node?
Outlook.
Outlook. Why?
Higher gain, information gain.
Yeah, higher information gain. We say that any attribute, okay, if it has higher information gain, it gives us higher or more information about the data set. It contributes more towards the data set. Okay, and this is the algorithm for the decision tree. So as you said, Outlook happens to have the highest information gain. तो उसके हिसाब से हमने डिसीजन ट्री बना लिया। ये सिर्फ 14 nodes, for only 14 nodes this is how long the tree has become. Now just imagine the 14 tuples, this is the tree length. Now imagine if we have 20,000 tuples or 20,000 input data items, तो कितना बड़ा ट्री बनेगा। Okay, so that is the main drawback of decision trees. Like उसका बहुत ही बड़ा tree बनता है, it's computationally very time consuming at the same time, और ऊपर से बहुत ही space भी occupy करता है। So let's look at the tree. Here we have taken outlook, and outlook takes three values: sunny, overcast, and rain. And sunny, when outlook is equal to sunny, we have 4 plays and 1 stay. So there's ambiguity here. Hence, we further expand the tree. We take temperature, and temperature takes 3 values: hot, mild, and cold. So उसके हिसाब से अगर hot है तो there is no ambiguity, cold भी है तो there is no ambiguity. We are reaching the leaf nodes. लेकिन अगर temperature is equal to mild, there is 1 play 1 stay. So we further expand the tree. तो यहाँ पे भी what we'll do, expand करके तब देखेंगे whether we are reaching the leaf node or not. तो ऐसे करके हमने पूरा डिसीजन ट्री बना दिया है फॉर दिस 14 टपल वाला डेटा सेट। ओके, तो यहाँ पे क्या हो रहा है कि व्हेन आउटलुक इज इक्वल टू ओवरकास्ट देयर इज नो एम्बिग्विटी। ऑलवेज व्हेनेवर इट इज ओवरकास्ट आउटसाइड, सानिया मिर्जा विल डेफिनेटली प्ले। ओके, सो दैट इज द idea. I mean, that is the decision or conclusion. So once we have created this data set, the question arises, for these tuples, what would be the action? When wind is weak, temperature is hot, sunny, normal. Looking at the decision tree, please tell me the output or what is the action. चेक करें। वी आर सेइंग आउटलुक इज इक्वल टू सनी, ठीक है, तो यहाँ पे आ गया, फाइन। उसके बाद हम कह रहे हैं टेम्परेचर इज हॉट, यहाँ पहुंच गए। जब टेम्परेचर हॉट है तो हमारे पास क्या है, 2 plays and 2 0 stays। तो इसका मतलब सानिया मिर्जा विल प्ले। इसका आंसर क्या होगा, प्ले। We don't have to go to the rest of the attribute values if we are already reaching a decision. On a similar note, when outlook is rain, okay, and temperature is hot, okay, this one is wrong here, it is hot. So she is playing, fine. So this is the way in which we find the class label for the input tuples, okay, using the decision tree. So this is how you construct the decision tree using entropy and information gain. और फिर paths के through, branches के through, we find out the answers to the unknown tuples. That means class labels या classification value जो है वो हम find out करते हैं. Using now the same decision tree, we can also perform a task called as rules extraction. ठीक है, यहाँ पे हम क्या कर रहे हैं कि we have 5 leaf nodes in the decision tree, and each leaf node can represent what they call one rule. Okay, each node can represent one rule. So if I say if it is sunny and temperature is hot, then play. If it is sunny and temperature is cold, then stay. So ऐसे करके we are generating rules. तो इसको हम rules extraction भी बोलते हैं. Like you can extract rules also from this. If it is overcast, then play, always play. If it is
Ma'am,
rain,
excuse me, ma'am.
wind is weak and temperature is hot, then play. ठीक है?
Excuse me, ma'am.
Yeah.
The second condition is sunny and the temperature is cold. Then that's, I think, on the right.
वो ये गलत हो गया था यहाँ पे डेटा सेट के हिसाब से देखिए. If it is sunny and temperature is cold,
Then play.
वो थोड़ा सा वो गलत हो गया था. Okay. So this is the pseudocode for ID3. And now coming to the disadvantages or shortfalls of ID3. So ID3 mainly suffers from something called as overfitting. Okay. यहाँ पे क्या होता है कि when you have a very large data set, जैसे मैंने आपको बताया, if you have 20,000 tuples and say 14 to 15 features, attributes, तो decision tree का size जो है वो बहुत बड़ा हो जाता है, like it becomes very huge. In the example just now, you have seen कि उसका depth कितना बड़ा है, कितना बड़ा भी लग रहा है tree. राइट वो सिर्फ 14 टपल्स के लिए ही है. अगर हम 20,000 लेंगे तो उससे बहुत बड़ा हो जाएगा. When it becomes very big, very huge, what happens is a problem of overfitting occurs. A problem of overfitting occurs. What does this overfitting mean is that ट्रेनिंग एग्जाम्पल्स के लिए तो सही क्लास लेबल देता है. Like for training examples, your decision tree would be giving you the correct class label. That means training accuracy would increase. Okay, it would be high. Training accuracy would be high. But then the testing accuracy, that means when you give a random tuple and see what class label it belongs to, sometimes if it is a binary classification, sometimes that tuple may fall in positive class. Okay, sometimes it may fall in the negative class. And when such kind of when this happens, I mean, you don't perform testing just once, right? You keep recursively performing the test. तो एक बार वो पॉजिटिव में आ गया, फिर उसको अगली बार हमने जब टेस्ट किया तो नेगेटिव में आया. तो ऐसे जब होता है तो टेस्टिंग एक्यूरेसी जो है वो घटती है. Testing accuracy जो है that reduces. So this concept where the training accuracy is high but the testing accuracy is less is called as overfitting. Okay, it is called as overfitting. And if you notice here also, as the number of nodes are increasing, okay, training error is shown in blue. Okay, and the error will reduce for training, but the test error is increasing as the number of tree nodes increase. So जैसे जैसे ट्री बढ़ेगी आपकी टेस्टिंग एक्यूरेसी घटेगी. ओके, although आपकी ट्रेनिंग एक्यूरेसी बढ़ी है. ये क्यों होता है? Because of ambiguity. Okay, because of ambiguity. Too much of learning हो रही है. As we expand the tree, the classifier is learning too much of information. When it learns too much of information, it will either put, sometimes it will put the tuple in positive, sometimes it will put the tuple in negative. And this is also called as purity of the data set. We say that when we start splitting the tree, when we start splitting the data on the top, that is at the root node, okay, purity is very low. Purity is very low. That means uncertainty is very high here. And as we keep expanding the tree, the purity increases. That means certainty बढ़ रहा है. Okay, certainty is increasing as we expand the tree. So this is the reason why entropy is also called as the measure of purity of a data set. Okay. So based on these factors, what we say is that decision trees, okay, tend to overfit the data. I mean, अगर ज्यादा data set से हम उसको बनाएंगे, तो फिर obviously overfitting होगी ही होगी. Okay. So what we do is, in order to avoid overfitting, we only select some limited data. Okay, we only select some limited data and some set of tuples. Okay, we only select some set of tuples. उसी tuples में से information gain की value हम calculate करेंगे with respect to attribute. ठीक है, और उन्हीं tuples के ऊपर हम training perform करेंगे. So that is the way in which overfitting can be avoided. Overfitting can be avoided. So let me just rub it off and revisit or repeat what I was telling you. I was saying the idea of overfitting, or the concept of a problem of overfitting, it can be avoided. Okay, if we select, okay, some set of tuples, okay, and some set of attributes. Or else you can also avoid overfitting by the concept of pruning. माने आप एक बार पूरा ट्री बना ही लो, ठीक है, बड़ा सा ट्री बना ही लो, बनाने के बाद ना ब्रांचेस को कट करते रहना. लेकिन जब ब्रांचेस को आप कट करोगे, when you cut the branches, make sure that the information is not lost. Okay, that is the condition. So this is called as pruning. It is called as pruning. So jab bhi, I mean, the plants in our house or the trees also, we prune them when the branches are overgrown. So the same idea we are using in decision trees. Now coming to the advantages, decision trees, they are very powerful for classification and prediction. Prediction के लिए we call them as regression trees. Okay, we call them as regression trees. ठीक है, इनका क्या होता है कि अगर हमें कंटिन्यूअस वैल्यूज होती हैं ट्रीज में, जैसे हमने बिगनिंग में देखा था, एज अगर एक फैक्टर है तो उसको हम ग्रुप करते हैं, तो ऐसे अगर हमारे पास डेटा सेट है तो उनके ऊपर प्रिडिक्शन करने के लिए वी कैन यूज द कॉन्सेप्ट ऑफ रिग्रेशन ट्रीज. तो इसके लिए भी लाइक एक 2 घंटे का क्लास चाहिए होगा बताने के लिए. Then they are very simple and easy to use because हम तो सिर्फ एंट्रोपी और इंफॉर्मेशन गेन की इक्वेशंस ही यूज कर रहे हैं, उसमें ज्यादा कुछ सोचने की तो जरूरत है ही नहीं, इतना तो कोई भी कर सकता है. So they are very simple. And the other one is they are able to handle both numerical and categorical attributes. Very easy to understand. The state is recorded in the memory. I mean, we can retrack also, backtrack also, where exactly, I mean, which root node or which child did we expand. So it provides a clear indication of which fields are most important for prediction or classification. And they can be well learned also. Okay. And coming to the disadvantages, apart from overfitting, the disadvantages are like each tree is a unique sequence of tests. So trees को हमें देखना पड़ेगा कि कैसे build करना है. Performs poorly with many classes and with small data. Small data also, I mean less data also leads to overfitting, by the way. ठीक है, अगर डेटा सेट कम है तो उसी के ऊपर हमें ट्रेनिंग भी करना है, टेस्टिंग भी करना है, तो फिर इस केस में भी हमें ओवरफिट हो जाएगा, बिकॉज आई मीन कभी सैंपल इसमें आएगा, कभी सैंपल उस वाले इसमें भी जाएगा, मींस पॉजिटिव या नेगेटिव में. एंड वी रिक्वायर एज मेनी एग्जांपल्स एज पॉसिबल. सीपीयू कॉस्ट बढ़ जाता है, they may contain error, etc. Okay, so this was the advantages and disadvantages of decision trees, and these are some of the examples: medical diagnosis, credit risk analysis, library book usage, and the last one is for the faculty. We can also predict if a student will attend tomorrow our class or not, based on the weather conditions outside and based on the attendance register that we are maintaining. So with this, I have completed the concept of decision trees. Okay. So this is the MNIST data set. Images means handwritten digits ka data set hai. And ये उनके truth values and predicted and true values. So it's almost like given the correct output.
Thank you so much, ma'am. Thank you, ma'am, for your wonderful session and your valuable contribution to our FDP program. Ma'am, are you there?
Hello.
I request all the participants kindly switch on the camera for a photograph.
Okay. I hope you guys understood, like,
Yes, ma'am.
I mean, this was the basic. इससे
Any
आगे
any
भी जाना
questions
था
from the
मुझे
participant side?
ensemble learning में, लेकिन time restriction है, इसीलिए मैंने हिंदी सबको समझ में आती है यार? Yeah, I was just like,
No, ma'am. It's totally understand your topic
okay,
and
okay,
your
fine.
thoughts. Thank you so much, ma'am.
Okay, yeah. Thank you. Bye.
Thank you all. We will start this tomorrow session at 11 a.m.